Algebra 2, Chapter 3 Review, page 2. Number 9. If a data set undergoes a scale change with a factor of 4, how is the mean affected? Well, you should recall Chapter 3 notes that under scale changes in data, the mean, median, and mode are multiplied by the scale change. The standard deviation and range are multiplied by the absolute value of the scale change factor. And the variance is multiplied by the scale change factor squared. So, since we're talking about the mean is just multiplied by the scale change factor. So you would say, oh, it's multiplied by 4. The mean is multiplied by 4. Mean is multiplied by 4. Now, number 10 is a good question. If each element of the data set undergoes a scale change with a factor of -6, how is the standard deviation affected? As I said, if my scale change factor is S, the mean, median, and mode you multiply by S. The standard deviation you multiply by the absolute value of S. The range you multiply by the absolute value of S. And the variance you multiply by S squared. Again, where S is the scale change factor. So for number 10, we're talking about the standard deviation. Well, we have to multiply the standard deviation by the absolute value of the scale change factor. The absolute value of -6 is 6. So, the standard deviation is multiplied by +6. I'll write this, multiplied by the absolute value of -6, or 6. Which statistical measure of data set are invariant under a What statistical measures of data are invariant under a translation? Well, the mean, median, and mode. Translation, again, is if you're adding or subtracting, like we were doing with number 7 and 8. The mean, median, and mode all change, but the standard deviation is invariant, the range is invariant, and the variance is invariant, meaning all three of those things do not change under a translation. Number 12. Given the function y equals 2 minus 3x, find the inverse. To find an inverse, first I switch x and y. So I rewrite my equation x equals 2 minus 3y. And now I say to myself, I need to get y all alone. So I subtract 2 from each side, giving me x minus 2 equals -3y. Now I divide by -3, and I'm all set. I get the equation y equals x minus 2 divided by -3. I'm going to rewrite that as -x over 3 plus 2/3. It's more proper. Is the inverse a function? Well, my favorite way to find if an inverse is a function is to graph it. I like graphing. So, in my calculator, I'm going to do x minus 2 divided by -3. And I'm going to hit graph. And I'm going to say to myself, does that pass the vertical line test? Why, yes, it does. So, yes, passes, the VLT. Yes, I just said excuse me to my calculator. Okay, number 13, we want to find the inverse of this one. Hey, same process, got to switch the x and the y. X equals the square root of 3y, plus 1. Let me get a little dotted line in here to show the difference in problems. There we go. Okay, so I switched x and y. I need to get the new y all alone. First thing I have to do is get rid of that lousy square root sign. So I square both sides. which gives me x squared equals 3y plus 1, because a squared gets rid of a square root. So this is what I did. Squared, squared. And I've got that. Now I subtract 1 and divide by 3, and I'd have y all alone. So minus 1, x squared minus 1 equals 3y. Divide by 3. I'm going to come over here now. I've got y equals x squared over 3 minus 1/3. That's my inverse. Okay, well, should just write it up here. X squared over 3 minus 1/3. There it is. Is the inverse a function? Who should I ask? This guy. So, plug this in again. I'm going to plug this one in. X squared minus 1 divided by 3. Ooh, does that pass the vertical line test? Yes, it does. So yes, passes the vertical line test. All right. Number 14, given the function y equals x cubed, find the translation image of 0, 0 on the parent function of the point 2, negative 4. Find its on its image. I'm going to write a rule and the new function because I'm not really sure what this one's asking me for. The rule would be x, y becomes, now since it translated down, I did a translation, it would be x plus 2, 0 became 2, so I must have added 2, and y became negative 4, so y minus 4. That's my rule for number 14. If I want to write a new function or new equation for this one, I would write it as y equals, and now instead of just x, it would be the opposite of this, which would be x minus 2 cubed. And I would technically have to replace y with y plus 4 right here. But if this was y plus 4, I'm going to go ahead and subtract the 4 off anyways, so it becomes minus 4. Okay, so my two answers here are that and that. 15, equation. We have a translation. Find the new equation. I'm going to write the rule anyways. The rule would look like this. I did x minus 3 and y plus 6. Basically, what happened to 0 to become negative 3? What happened to 0 to become 6? Well, this did. To rewrite it in the equation is going to become y equals, that negative just stays out front. And now, instead of x, I'm going to have x plus 3, the opposite, squared. And then again, this y plus 6 would really be y minus 6. But then I'm going to subtract, I'm going to add 6 over here anyways to get it on the other side, so that would be my equation. So the x ends up switching, and the y looks like it never switched at all. 16. Graph this function and tell if the inverse is a function. Alrighty. So y equals x squared plus 3, graph. Is the inverse of that a function? The answer is no, folks. Because in order for the inverse to be a function, this would have to pass the horizontal line test, and it doesn't. So I'd say no. Doesn't pass the horizontal line test. No, it doesn't. Number 17. Name the parent function whose graph most closely resembles this. This would be the cubic function, y equals x cubed. Okay, and you can look on your parent sheet for that. Symmetry we didn't do in this course, so you don't have to worry about this. To graph the inverse, remember, inverses are reflections over the line y equals x. Okay, so if you were to graph the inverse of this, it's going to end up flipping to look something more along this line. Okay, it's centered on the x-axis instead of the y-axis. And that's the end of that page.